So we're going to talk about self-deploying applications, but we need to understand why I think it's possible in the Go community. So one thing that I find unique of all the runtimes and language environments that I've used, one thing that makes Go unique is this idea of the Go runtime and being a compiled language allows us to create these self-contained binaries, right? How many people like this feature of Golang? Right? It's like my #1 feature. If you didn't raise your hand, I'm going to show you why it's amazing. It's simple, but it's amazing. So when we think about deploying an application, especially a Go application, we compile the program, we copy the program to the target system, you start the program. There's a bunch of things that happen, especially if you're using an ELF binary. We need to get this thing loaded into memory, the kernel takes over, and passes control to our program. If you come from a different programming environment, it's usually a lot more steps than that. In the Go world, this is the most beautiful thing about Golang. Creating statically linked executables can be done in a single line like that. So here, I'm just going to use this build script to create that statically linked self-contained binary. And most of our tools, the way we think about deployment comes from this particular flow. You build your app. I'm not going to copy it to the other side to save time. It's already there. And then I SSH to a machine. And then our goal is to execute this particular binary, right? It's a very simple binary. So we'll jump on this machine, and we'll just run it. Okay? So this is called Hello Universe. It's called Hello Universe because it's bigger than the world. So this is next level stuff that you're about to see. So what we want to do is we want to see how this thing works. It's a simple application. So I want to hit on this public IP just to make sure everything is actually working. This is all live, so if anything doesn't work, it's probably not my fault. I need the Wi-Fi, so now's not a good time to update your computer, okay? Let me use the Wi-Fi. So we hit this, and then we'll see. We got to test the demo, guys, with a small offering. Okay, and 8080. All right, so far, so good. Hello, universe, okay? And that's the process for most Go programmers, right? So we say, hey, we have this self-contained application. We're doing great. So then we move into the next question is, what happens when you have more than one machine? Right, now this is when it gets hard. Anyone ever heard of DevOps? So DevOps is group therapy for developers and sysadmins because the problem gets super hard when you have to target multiple machines. So in our case, we have a cluster of machines where a lot of this workflow goes away. So let's get off of the single machine. So what we have is a couple of machines. We have 10 of them in this particular cluster. One thing you could do is, if you're a for loop, SSH all your binaries into each server, start them, or you can invent this thing called configuration management where we have something that automates that process. For the last 10, 15 years in system administration, we haven't really moved the bar too much, just automated this kind of one single deployment mindset. But one thing we could do is adopt some things that we find in the container world, right? So we're going to go from this self-contained binary, and then we're going to have to bring in all this extra tooling so we can target more machines. And you haven't seen this in action. What you would normally need to do is create a Docker file. So we need a kind of a resource envelope to put our self-contained binary in. We're going to put it in the box. So then we can use a different tool. In this case, we're going to use Kubernetes to push our application to all of those machines with very little effort, okay? So first thing we need to do is get that statically linked binary. We have that running, all right? The next thing we need to do is create this Docker file. So we'll do Docker build here. And what this will do is take our statically linked binary, and you'll notice that this Docker container is going to be really, really small because I like to do my builds outside of my container image. So I'm going to push this up, and this will spit out a Docker image, okay? Now, the next thing we can do is we can test Docker locally, and if it all works, we can push this Docker container to a repository. Now, since my goal is to support multiple machines and not a single machine, I'm going to use a cluster manager to do that for us. So what I need to do now is describe what that looks like. So most of these tools have some way to define your application. So there's that container we just built. And here I'm saying, I would like this to run somewhere in that cluster, okay? So we want to take a bunch of machines and make them look like a single machine. So here I'm going to send this particular description to Kubernetes so that it can run it for us. All right, so we'll create this. So what should happen now, if things are working, I should have one of those applications running. So that's my container. And let's say I want to have multiple copies of it. So we'll see what that looks like. So this is great. We're learning all this tooling that allows us to do this thing. So we'll apply these changes. Great. So if I look at this now, we have now 10 copies running somewhere in our cluster, right? This is great. Now, kind of the drawback here is that I have to learn all of this tooling, bring in this container format, even though my binary is self-contained. Let's make sure that this is actually working. So kubectl, get svc. Now we get a single IP address that lets me, let's make sure we can actually hit this. All right. Yep, and we see it. So each of these has its own host name and network namespace. So we can flip through there and we see that our application is now running across multiple machines with little effort. Now the problem here though is that you again have to learn all of this tooling to make that work. So the nice thing about Golang is that it's all self-contained. You build the application and it's easy to deploy. So this quote came from one of the Google legends, Urs, and his fellow author of The Data Center as a Computer. We must treat the data center itself as one massive warehouse scale computer. So what I just went through was the idea of doing that, taking all of our machines and making it look like a single machine. But the problem is our application, the benefits we have from Golang, are lost in the deployment process. What I would like to have is that self-contained binary also be something that can self-deploy, all right? So what we want to do is start to think about what does it mean to be a self-deploying application? Well, we know we need to compile the program. That can't go away. The program also needs to be started. But if we're going to think about the data center being the computer, then we get a lot more in the data center. We're not dealing with a single file system or a single POSIX target. So when we say load the program into memory, that can actually be something that's federated. Okay? We just need the binary to be available to be loaded into a machine. And then also, we need to challenge the idea of where the kernel is. Okay? So the kernel in our case goes from just a single machine to Kubernetes itself, the cluster manager. All right? So we're going to trade the syscall interface of a single machine to the APIs of the cluster manager, right? And given the current Golang runtime, all the things we need to start a process on a single machine are built in, and then we hand off to the kernel so we can be loaded, and then it hands it back to us to do any other syscalls that we want. So we want a very similar flow for our Go binaries, right? I don't want to teach people everything about Kubernetes to do that. So let's see what the world would look like if we had a binary that could deploy itself, okay? So we're going to go back and remind ourselves what our current program does. So let's make sure we clean up. So we'll delete this current one. rs hello universe. All right, so that's cleaned up. So let's look at the application again. So we'll just do go build. And I also don't want to create a container first. I would just like to use my static link binary. So the first thing we're going to do, let's just do go install. All right, so hello universe. We'll listen to HTTP on my local machine. And we're here at 8080. All right, very simple program. Let's make sure that it actually works. 127, 8080. All right. I'm pretty sure Google IT is like, what the hell are you doing leaking your host names? But we can edit that out. Security's like, oh. All right, so we see this simple application just works, okay? So here's all the logs from it, all make sense. So I want to take the same application, but I want it to deploy itself. So we have all of these nodes, but I don't want to create all the other stuff that we just went through. So it would be nice if I could teach my program how to deploy itself. All right? So now I have a library called cargo with a K. And cargo gives me all of these flags if I import that library. And I can fill out a little bit of code And now I get all of these things to allow me to express how I like to be deployed to the target system. Now, the cluster that I want to deploy to doesn't currently have my Go binary, and I don't want to build a Docker container. And there's some tricks we do underneath the covers. So here, what I want to do here is I'm going to enable Kubernetes, and also I'm going to say how many copies I want. So you can think about this as how many threads would you like to run. Except in this case, or Go routines, except in this case, I'm going to have multiple containers running throughout a cluster. So here we'll say replicas equal, someone give me a number? 742. We'll take 10. This guy has 20,000. That's the person that wants you to fail in your live demo. Failure. All right, so here's what we want to do. So what we want to do is target a cluster. So I'm going to run my client in command line so I can actually choose what cluster I want, okay? So I'm going to run this now. So the first thing I need to do, since I'm on a OS X, I can't run this mock binary in my cluster, so I need to compile a version of myself that will work at the target. Once I have that, I take the SHA-256 and I load it into memory. In this case, this is going to be a Google file storage bucket. And once it's there, I'm going to copy those things up and make accessible in the cluster. And then what I'm going to do is go take all 10 of those processes that are running somewhere in the cloud and grab their logs, okay? So what should happen now is if I go back and I look at that service endpoint, we should be able to see what happens, okay? So we come here, and we'll get some traffic. And what you'll see is that my application is proxying all of those logs back to my standard console. And if we look inside of our data center computer here, kubectl, get pods, we'll see that they're all deployed, okay? So while my application's running, it launched itself into this data center as a computer. And if I were to exit out of this application, you catch your shutdown signals, and your goal is to clean up after yourself. We don't want to orphan any processes. So now if I look at this, we see all the pods are gone. So we're just treating these targets just like a single machine, okay? So when we think about this, we can actually go and keep that same self-contained field that we have in Golang, but target any computer, even this idea of the data center being the computer. But then here's a quote of mine, right? Like just now. So we're in this cloud world now, and even for the smallest startup, people assume that your application will be available globally, right? So it's no longer acceptable to have it in one data center. So now I'm saying we should treat the world itself as one massively global scale computer, right? So what does that look like? So imagine a world, now this is where we get to highly experimental. I'm gonna give you a warning. The demo guys have been nice, but we're about to tempt them a little more. So let's say clusters, list. Let's make sure we spell things right. So container. I love it when they pay attention. So we have 3 clusters, okay? For those of you that can't read, that's Asia, Europe, and the US. And this is where it really gets challenging, okay? How now do you target all 3 of these clusters and get the behavior that you want? We don't want to go through the process that we saw before. So in this new global computer, we actually have a different interface called federation. This is where we take multiple clusters and make them look like a single cluster. And we get the same benefits that we had with the cluster that made a bunch of machines look like a single machine. And now let's look at what it takes for our process to run in that context, okay? So we want to do the same thing. How many copies should we run? 50. Someone said 50. This is like not working territory, but you know what? Let's up the ante. We'll do 50. Demo gods. See, as a speaker, you have an opportunity to go back and do something sane. But you don't. All right. let's make sure. Whatever. All right, so our goal is to run in all the clusters, and let's see what we get. So we're building the binary. And we want to make sure it's already, so here's our output, it's already there. We're creating a replica set. And then now, our goal is to see if we do have a global deployed application. So we'll say in the context of EU, things are happening. Okay? In the context of the US, things are running. In the context of Asia, running. Let's go back to the EU. And let's see if it's real. And in order to have a global computer, we need a global naming service, right? So what we'll do is we'll grab any of these. We'll grab this one, which will proxy our traffic over every computer in our global namespace. Let's see if it works. Oh, I'm dropping the mic on that one. That's it. We have a globally distributed application.